DraftScience video response to the whatever critique by this person. Yeah. No doubt will be useless, but I will make utility out of it, and it just gives me opportunity to do some clarifications if necessary. So let's play along and see what happens. I haven't watched this yet, so let's see what happens.
For example, at one point in the dialogue with Pyro, he talks about the acceleration in a vast centrifuge being unbearable.
Not unbearable, but no. I was trying to create an illustration that would explain how velocity destroys structure eventually. That it's a degrade. That the idea of cryogenically, okay, of doing this movement stage left, alright, you're dancing, you're doing your orbiting thing. I require your orbit to spend some portion of its time moving in a direction, and as I do that, I start degrading your metabolism, and how that eventually will break down structure. That you can only run so fast to the left, and eventually there's no dance anymore.
That you would disintegrate.
So yeah, I used a off the top of my head example of how you can get the idea that, like in a cyclotron, the mass is destroyed essentially. It's broken down into its little bits. The more dense ones are pushed further down, and then the lighter ones, volume-wise. It's by density. And yeah, I can defend that. I mean, it's obviously, it gets a little complicated because it's a circular thing, not a straight thing. But you can get the idea that the circular thing is just a straight thing trapped by force. And so when you release it, it goes straight. So it is the velocity that's really doing the degrading.
But unfortunately for him, and is often the case, he says velocity, he says acceleration of velocity, and you'll find this is real low-grade high school physics understanding, that he cannot consistently use these separate terms, the terms of velocity.
Oh look, I've made the distinctions in my videos that acceleration is the acquisition of change, of imbalance. That you are now being imbalanced by, and that's acceleration. And velocity is maintaining the imbalance until something changes it. So yes, acceleration is moving stage left from a stationary position, from a position where you're just dancing. And velocity is just maintaining that movement once you've established the movement. It's probably the dancing analogy doesn't really work for velocity and acceleration. But the difference is that at one point you're changing, and at the other point you're just maintaining the change. So velocity is the maintenance of the change, and acceleration is the creation of the change.
Velocity and acceleration independently. You see, circular motion is always by nature an acceleration, because the direction is changing, and acceleration is a vector quantity.
Well, it says you, right? So I'm just basically arguing that no, you can turn that right around, okay? And I can argue that what's really happening is the only thing growing is the velocity, and that the acceleration is constant. So if it's constantly it's accelerating at a constant speed, and then it reaches its maximum velocity in the sense that it's reached its maximum acceleration. It doesn't. It's not growing any faster. That the force still exists, and it's created by the velocity essentially. The velocity is the only real component, and the acceleration is an artificial one. Let me see how to put this. It's the velocity is doing the damage, and it's making it possible for any other influence to break things down. So it's like velocity is what is degrading the structure, breaking down the forces of the atomic structure. And so now any amount of force in a direction will migrate the bits. Now the bits are much easier to migrate because they're only loosely fixed. The other point I would make about velocity, well I don't know. Well, we'll see what else we say.
But velocity is something completely different.
Well, it can't be completely different. I mean, the two things are quite obviously very well connected. One is, again, I have a disposition of arrows inside of me, and it's balanced when I'm not moving, relatively speaking. And when I change and I start moving, relatively speaking, it's because something has changed inside of me. That means I have absorbed from the field energy in a direction, and now I've changed some pieces of me. I've exchanged a direction this way for a direction that way, essentially, and I will move in that direction, and I'll keep moving in that direction because that imbalance exists until some other force, as Newton would say, is going to tell me I can't do that anymore. It's going to give me a new imbalance. And so with something moving circularly, all that's changing is the same velocity number, it's just changing the direction. So you're not changing how many of my arrows are pointed in a different direction, the imbalance, you're just changing the vector of the imbalance. And I would argue that that doesn't absorb any energy. There's no energy involved, so there's no acceleration portion, because the change is an acceleration, the change is in the direction of the velocity, and those two things are different.
Is fundamentally different. Where one is the rate of change of distance with respect to time.
Yeah, well, I mean, that's your way of looking at it. What I'm saying is that distance, the illusion of distance has to be understood in the concept of your matter being made of constituent distances, the constituent directions. So obviously, again, the photon is the standard, okay? It's moving a certain distance per a certain unit of time. Now, a piece of matter that has a circular orbit can't move as fast as the photon unless every one of the little orbiting bits is moving in the direction of the photon. Quite obviously, in an orbit, they're not all moving in the same direction, so they can't possibly move the matter as fast as the photon. So I'm just arguing, as you start moving matter faster, it means you have to make all the bits point in the same direction as the photon's direction, which means there is no longer any circular structure. There's no orbits left.
The other is the rate of change of velocity with respect to time, that being acceleration.
Again, these are your definitions, and I'm saying fundamentally, look, you're either going to argue the fundamental particle theory or forget it, okay? I mean, if you're going to just argue from me, it's written in grammar school books that there's an electromagnetic spectrum and that photons are waves. Well, yeah, that's what the grammar school book says, but it's wrong. I mean, fuck you. I mean, I'm not going to argue the non-theory. I mean, there's no point in taking what I'm saying and then putting in the context of their model. It doesn't fit in their model. So preaching, again, telling me what Jesus says, I really don't care what Jesus says. Tell me how I'm wrong. Don't tell me how their theory is different. Yeah, their theory is different. I'm not accepting their theory of reality.
One involves no force, and the other involves, as per Newton mechanics, a force being involved.
Well, all I'm saying is quite obviously in my argument, velocity, inertia is no force. The force has already been injected. It exists. It's a quantity. It doesn't need to be re-energized. It doesn't need a constant push. There's no such thing as any energy involved in this velocity thing once you've established it. It's an imbalance. It remains an imbalance until something unbalances it again. Period. Force must interact and change the imbalance. Till then, the imbalance exists, the thing moves.
Thus, it is known and understood that
again, it is known and understood. I'm supposed to say, gee, what a great argument. It's known and understood. No, it's fuck that.
Spacecraft travelled for about, I've heard this, I've never checked it out, but I've heard, and it sounds about right. If a spacecraft travelled with acceleration of 1g, that's the same as what we experience in the gravitational field here on Earth, just stood here on the planet. If we had that acceleration within about a year, we can achieve maybe 50 or 90% the speed of light.
Well, you think you would know the difference, but yes, yes, you can get to the speed of light. Now, the argument is that physically possible? So one scenario I'll just paint for you, okay? Now, what's going to happen as you're going faster and faster is I'm going to argue, say you're going half the speed of light. That's a really easy number. That means half the time your molecular structure is moving in a direction rather than doing any orbiting. So think of the solar system. And I'm arguing that basically what you're doing is you're taking everything's orbit and saying go this way half the time. So you're going in one direction half the time. All the planets, the moons, everything has to go in that direction 1/2 of the time. But the rest of the physical mechanics are going to be the same in the sense that it still needs to, the 365-day rule, all these kind of rules are still going to exist. The initiation of gravity, all those forces are still going to be, they're still functioning in the old time scale. They're not in any way changed by this. So simple arguments would be, as you're moving this quick speed, your matter is now very unstable. Something could hit your, just when you're going to stage left, some meteor hits you and now pushes you even further stage left. And now you get too far out of the gravitational field and you fly out into empty space. You see what you create vulnerabilities because it creates an intrinsic instability in the material function, because none of the gravity or anything else is any stable anymore, because now you're changing distances between parts and you're not doing it all at the same time. Each bit is moving at different points at time in that direction, so it becomes unstable matter. Further, if I did this and I was going half the speed of light as a spaceship and I'm moving half the speed of light through space, everything coming at me, okay, that is light, that has a frequency, is now going to have a frequency that is twice as fast as it was when I was going some much slower speed. So merely light rays coming at me, their frequency will now be compressed because I'm moving into them twice, at half the speed of light. And so, just regular visible light becomes X-rays. The energy of everything I'm contacting with that has a frequency is now increased dramatically because of the speed I have. I'm crashing into it, and the period, it's not moving faster, but the period, its frequency, is radically changing. And so now, and secondarily I would say, and as my matter now is in this unstable condition, if something hits me from the side, okay, it's going to be much easier for that thing, whatever that entity is, it's going to be much easier for it to destabilize my material structure. So any damage done from any kind of radiation would be greatly magnified by the fact that now my matter is very unstable. This should be a picture that's visible. And ironically, again, if I move it going the speed of light, if it's going the speed of light, it just basically means if you have matter going the speed of light, it means that everything in the matter can't be doing any circles, or it would be going faster than the speed of light. You can understand that, can't you? That if it's doing some orbiting thing, at the same time it's moving the speed of light, that it would have to be going faster than the speed of light, because everything going in the top of the circle would have to be going faster than the speed of light. How else to say it? That there's no time to go down or up or backwards. If you're going as fast as the speed of light, how does anything have time to go down or backwards or up? How is anything called an orbit going to be maintained if you're going the speed of light? It's the same space out there that's in the nuclear space. So I'm just saying, if you have any conception of an atom having an electron orbiting around it, or any conception of maybe those particles themselves being stuff in spin, stuff spinning or orbiting, how can any of those orbits be maintained if it's moving as fast as the speed of light? How can they go that way and this way and all these other directions while they're going as fast as the speed of light in that direction? Where do they get the time to do that?
Without any discomfort in acceleration.
Yeah, well, it says you, without any discomfort in acceleration. So you just basically said something can travel the speed of light and it has no consequential effect on your internal structure, and the universe you're crashing into is no different. Where I think we do know, just the example of that probe that went to Pluto and it was traveling very fast, 30,000 miles a second or something, and they were concerned that it might hit a speck of dust, okay, and be blown up. Because, yeah, the energy of the dust is now increased by the velocity. The velocity is degrading the structure. Is technically what's really happening, is the velocity is making the thing that's moving really fast vulnerable to just a tiny interaction.
So, Inmendham has a problem.
Well, whatever. I mean, these useless characterization. There's not one argument here that gets into anything I'm fundamentally arguing, which is a particle description of the foundation of physical phenomenon. You're not getting to that theory, and there's just, again, no point in taking what I'm saying and trying to squeeze it into well, you can squeeze it into Einstein. I've already explained how the bent space is just a convergence, and that he shouldn't be using, well, I don't even know if you're watching those videos. Yeah, so maybe there's no point. No point in me being redundant.
Insofar as he never specifies what the absolute frame of reference is.
The absolute frame of reference is the speed of light. It's the same constant. It's Einstein's constant. That's the constant, the speed of light. Everything else is some lesser speed, all the way down to 0. But that's it. Matter can't move as fast as light because matter's doing something else. That's the whole fucking argument. Matter can't go that way, the speed of light, because matter's doing this inside. It's spinning around in circles, and it can't spin around in circles and go the speed of light. But that's the absoluteness. The constant is the speed of light in the speed of interaction, let's call it, because that's what I'm arguing is taking place. The only reason why light takes time to get through space is because space is full of gravity, and the gravity is an interaction, and the interaction has a time. So the density of the gravity will dictate how fast something will travel through it, in the sense that, let's see, how's the best way to put that? It determines the number of interactions, and it's the interactions that take a little quanta of time. Otherwise, it'd all be instantaneous. But every square, there's all these little tiny pixels of space, okay? A trillion billion times small, okay? A million billion plus a million billion, getting smaller and smaller, until you get to the real quanta distance. It's this little teeny bit of distance. And in matter, the distance is even smaller. And in empty space, it's a little bigger. And it's the time of those interactions. The number of interactions you have depends on how condensed the bits are, how close together they are.
That becomes a problem for travelling at high speed. Yeah, he supposes that everything degenerates into raw energy and photons. In fact, on the photons front, he said there are no photons, they turn into X-rays and gamma rays.
Yes, they're all the same thing. They're made of quanta. The only difference between a photon of light and an X-ray is how often the quanta come. Period. That's it. The period between them. The distance between them. Radio waves, really big difference. Gamma rays, cosmic rays, really tiny distance. Same quanta, distance is the variable.
At one point in the thing, which is another foot in mouth situation where they are
again, this useless editorializing, baldy.
Electromagnetic rays and consist of photons, right?
Magnetic rays. All right, let's go back to this. I never called them rays. Magnetic rays ever.
Which is another foot in mouth situation where they are electromagnetic rays and consist.
Well, again, I've never called them electromagnetic rays ever. So lie some more.
It's the photons, right?
I've consistently, from the very first video I made on this subject over a year ago, I've contended that photons are gravitons. That's what they are. They're not electromagnetic anything. Gravity isn't electromagnetic. Photons aren't electromagnetic. There's no such thing as electromagnetic anyway, because that, in a sense, is made out of gravity in the end anyway. But there's no such thing as any spectrum of this electromagnetic bullshit. There's frequency between quanta, period. That's it. That's the only quality a photon of any type of energy has, is its period between the impacts and its polarization. That's it. It has no other suitcases. It has no other books. It has no other information. It has no other quality. It's a discrete bit moving the speed of light in a consistent direction until some force forces it to do otherwise. And usually the force has to be a gravitational well.
Pyro is a better man than me, for sure. He's a better human being than me.
Wow, another irrelevancy in the physics video.
I would tip my hat to that.
Pyro's a douchebag, but whatever.
His tolerance,
his baggy pants, his bell bottoms, his shiny buckly shoes, his high heels. I mean, he's just a frickin' dumb loop-de-doo hippie.
Actual, no bullshit, really, no taking offence, an ability to set aside, pass.
Oh, will you just get to the physics, please?
Acrimony is second to none on YouTube. I mean, utmost admiration of that.
I guess I should have played it. I didn't know he was going to do bullshit in the middle of the video.
Right,
Should have expected it.
The other thing, right, so another thing, the most basic thing, he has this articulate idea of why, right, which cannot explain.
Good, finally. It can't explain something. That's what I'm looking for. You tell me it can't explain something. Good, let me hear what it can't explain. I'll explain it.
How a laser can pass through a prism or any piece of material with a refractive index.
Right. So, how can I not explain that? They're particles. The surface is not regular. The particles hit the surface that's irregular, and based on the distance, the frequency, they move a different way because the electrons that they're sensitive to are different. We already know that, don't we? Don't we know that different electrons and different energy levels will absorb different kinds of light and then reflect other kinds of light? So we already know that. And then with visible light, we know that it has these frequency gradations that, depending on the frequency, that you'll change the angle based on hitting something at an angle. Quite clearly, the electrons are in a different position as you change the angle. So if I have a bunch of things looking this way and I bring something consistently at this way, they'll leave at different angles because of this fundamental angle you've created.
and still remain as a laser and doesn't disperse because of the particulate nature of all these interactions. Yeah?
Polarization is an issue, okay, and certainly the colonization of light is another issue. So much like the atmosphere can only absorb so much ultraviolet light, and then the mechanism that absorbs it breaks down, and that's it. Though the rest of the ultraviolet light gets through because the mechanism that absorbs it breaks down. There's limits, and laser beams often exceed those limits. But I don't know exactly what your point is, so I guess I'll try to wait until I get to it.
If light truly is these, and everything's made up of the same thing, its tendency when travelling at velocity and hitting objects of random configuration would be to split up, right?
I don't know. Does that really fit what's happening? What I'm saying is an electron is an orbiting system, like a solar system. The photon comes into the solar system, and the idea is it has to create balance to stay there. Somehow when it comes in, there has to be enough gravity to keep it. So what first happens is it catches it, but it doesn't quite have enough gravity to keep it. And the catch is that the second photon comes in at enough time to create enough gravity to catch the other one. And that's when it gets captured. And then when there isn't enough, when they're too distant in frequency or too close in frequency, that pattern isn't created. You don't create enough gravity to bind them, and so then they are released. And they're released at some angle specific to that wavelength. I mean, this is kind of known about photons, okay, is that, you know, you shoot them into some substance, and depending on the energy level of the electrons will either be able to absorb them or they'll just reflect them. They'll re-emit them.
And be absorbed.
At a different frequency, often. Blue light goes in, a piece of red light and a piece of green light comes out, that kind of thing. Certain amount of energy goes in, certain amount of energy goes out. Sometimes the electron will keep some energy, sometimes it'll just release all of it, but it'll release it in two different packets of energy. Two different photons will leave. One photon stream goes in at a high frequency, two streams leave at lower frequencies. These things happen in reality.
He has no explanation for that.
I just don't buy that argument. I haven't been asked to blueprint this specific phenomenon. So to say I have no explanation, where have I been challenged to provide an explanation? I didn't know you wanted me to give you an explanation. I haven't gotten any answers to my questions about two-slit experiments, all the other things I've asked. I'm asking why there's lensing outside of a lens in space. How exactly does the low gravity area create lensing? I'm asking legitimate questions. I'm not getting any fucking answers. Where did you ask me this question previously where I gave you no answer? Where did you ask it? Point me to where you asked me this question, I gave you no answer. Now, you want to give me a specific, show me a PDF to take me to a Wikipedia. What exact phenomenon do you wish me to explain? Laser beams going through prisms and the light doesn't get refracted. Laser beams are generally monochromatic light. They can't prism because they're made of one color of light. So right there, I guess I could argue that laser beams don't work in prisms because they're monochromatic light, and you can't split monochromatic light. How's that?
You can watch number file, not 60 symbols video on light and glass to get a handle on the significance and the intricacies of the problem of considering how light moves through a medium. And it's far from simple, even from the quantum mechanical.
Yeah, well, they don't even have a straight answer. If you watch that, there's two different physicists who give two different explanations. So, what's your argument here? Yeah, there's the circumstance of the light appearing to move more slowly. But I think both physicists are both saying, I think, essentially, that the light doesn't technically move slowly, that it actually goes through some sort of mechanism where it's challenged, and so it has to move more distance. It doesn't move in a perfectly straight line through the medium. it interacts through the medium, and it takes time for it to do those interactions to get through the medium. Is that the video you're talking about? And what does that have to do with me again? What does that have to do? How does this negate photons as particles? Gravitons, quantons. How is this proof the theory can't work?
Point of view. It however seems firm and explanatory, granted. But what is true is, through listening to discussions, that the idea that it's particulate moving through particulate in an only, as Inmendham puts it,
yeah, how Inmendham puts it is that photons can only be affected by, they can only be changed in their direction fundamentally by gravity. They have to go into a circumstance of nuclear gravity.
Velocity, collision, transfer,
kinetic
dynamics. It's clearly troublesome.
Yeah, well, again, clearly by what, how exactly is it clearly, how have you demonstrated any clear troublesomeness? I don't see it. Feynman called light corpuscles. The idea that the light is a quanta is not outside the reach of many physicists. So the idea that this quanta of energy interacts with matter is not impossible to imagine.
He talks about time dilation and muons existing longer, and yet he has no theory of muons.
Well, I mean, what is my theory supposed to be? They're not photons, all right? A muon is something with an orbit to it. It has structure. It has some quarkness, okay? It's more than one quanta in an arrangement. So whether there's two quantas spinning around each other, whether there's only 500 or whatever a muon might be compared to an electron, I would imagine they're heavier than electrons, okay? They're radioactive bits. But regardless, it doesn't matter. The point is they're a solar system falling apart is the argument, right? That they get energized in the atmosphere, they get created, and that these things, these pieces of the structure of atoms, it gets knocked out of an atom, it's an unstable arrangement or solar system, it's already falling apart, and the argument is that it falls apart slower if you move it faster, because yes, all the cycles of its gravity and its orbits takes longer to break down because of the velocity. It can't expand. Let's say it's an expansion that defines its decay. Let's say that's how it decays. It decays by just expanding and turning into energy, radioactivity. So it's expansion that destroys it. It can't expand at the same rate if it's traveling a distance. So again, it's like the dancing argument. It can't dance in if it's got to dance in wider and wider circles, and I say go that way, the circles are going to get slower and slower. So it's going to take it longer for the bits to decay the faster it's going.
And why muons exist?
Why they exist is not under dispute. Again, why do I have to explain why they exist? They already have a theory of why they exist. I'm not contending that the theory of why muons are created is in any way inaccurate. I don't even know, but I don't give a damn. We know that cosmic rays hit the atmosphere, muons are knocked out of whatever atoms they're in, and they're decaying little bits, then they usually decay really quickly, and the point is because they have now a high velocity, they don't decay as quickly. Everything I've said is completely consistent with those truths. God, you're just so obnoxious.
And when things like antimatter get voiced,
well, it's not antimatter, because when the two things collide, it's not zero. It's a bunch of energy is released. So it's not antimatter, it's disrupting matter. It's like me and you, oil and vinegar. We don't mix. When we collide, blood and tissue is likely to fly off. Asshole.
he says things like, no, that's wrong. What I'm saying is, yeah, it's like this.
But Michael Sandel says, Michael Sandel says. So I mean, every time you're going to say some creek about some bullshit about me saying I'm just saying, then I'll just point out how all you keep saying is Michael Sandel says. Asshole.
It's like this, and the truth is, we see in bubble chambers, you know.
Oh yeah, bubble. We see in bubble chambers. This is where physics really, wow. You know, what we don't really see, you know, bubble chambers, the whole idea is that this is like an Etch-a-sketch or something. And you're saying, oh yeah, look, we're seeing something, but what you're really seeing is just the big bits. You can't see the little bits, and you're just seeing light reflecting off of big bits. So again, it's a really not a very good, it's not a very good microscope, you know, a cloud chamber. You know, you're drawing in sand, and we're talking about particles 1,000,000 times smaller than sand.
In a magnetic field, an electron will follow this arc at this speed, and we follow something else following exactly the same arc, the same speed, and through calculations and other experiments.
Again, I'm just disputing the word antimatter. It's just not a rational use of words. Okay? It's not antimatter. It's matter that is incompatible. But it's not some other form of energy. It's not completely unmatter. It's just matter in a configuration not compatible with that piece of matter. So it's like two things that are magnetically attractive, and they'll crash into each other. And they'll become something else. Well, they can either become something else or they can explode. Right? You can mix two ingredients and the two ingredients can just mix together. They're fine. You can mix two ingredients and they explode. We don't call, you know, you don't call hydrochloric acid antimatter because it doesn't agree with very much. Do you? Does everything, is gunpowder antimatter because it blows up?
We become sure that this is the anti-version of the electron. It's the positron. And we have...
Well, again, it's not an anti-version. Okay? It's just the wrong way to describe this function. It's made of the same quanta. It's functioning the same way as the rest of the matter in the sense that it has mass and all these other constituents. It's a thing. Okay? You want to call one of them black and you want to call them white and you want to say they're having a race war. Fine. But you don't call one of them anti. They're both matter.
For every particle, it's antiparticle. And he has no theory of this.
Yeah, I have absolutely nothing to say about anything called antimatter that has mass. That's right. I think that's a ludicrous thing to say. You don't call something that's antimatter and then say it has mass. That's retarded. So if they're going to say that the electron and the anti-electron collide, and twice as many photons are released as a single electron being destroyed would release, or what we know to be the energy of a single electron, then I guess you can't really call it antimatter. I think that's a retarded explanation. Antimatter would be something where it collides with matter and it just consumed the matter and ate the energy. That would be antimatter.
In fact, when he's discussing the principles, very often he talks about the electron doing things, when really the electron isn't a fundamental particle.
Well, again, and when did I say it was a fundamental particle? So, where? Point to me one video where I said the electron is a fundamental particle. Where did I say it was even a particle? I mean, my whole point is it's not a particle, it's a system, it's a solar system, it's a mechanism that's full of bits. It has all kinds of identity. It has all kinds of shit going on inside of it. It has 1 million constituent parts moving around each other.
He'll talk as though he has it as a fundamental particle, and he's described...
Well, again, I haven't done any such thing. I haven't described it as a fundamental particle. That's just a lie. The very premise of my friggin' philosophy on this subject, the very premise of my physical theory, is that the only thing that is a particle is the quanton. Nothing else is a particle. Everything that has mass has to be something in orbits around each other. There's no other thing, there's no other way to make mass. There's no other way to qualify anything of mass. It has to be stuff orbiting around each other. It has to be quanta orbiting. That's it. So lie some more. I mean, really, there's just no video you can pervert into this obnoxious paraphrase of what I've said. I've never said an electron is a fundamental hard particle, ever.
Why it exists as a particle in itself. Why isn't it a proton? Why doesn't an electron change into a proton?
Well, because of the rules of the polarization and the evolution, no doubt, of the limits of gravity and the limits of the physical dynamic. Okay, it can only get so big, and then it crushes itself, in the sense that you can imagine that a body, just by the workings of gravity, you can imagine that something could create so much gravity, in the sense that it blocks so much of this force, that at its center the force is de minimis. And that means the atoms in that center would no longer hold any structure. The atoms would have no force pushing them anymore. So all the external force disappears. That means you can't have a lack of pressure in between them, right? You can't have an imbalance in pressure to hold this system together if there's no external pressure that can get to the atom. And then the atom explodes. It basically releases zillions of whatever they call them, joules of energy, and boom, the thing blows up. Supernova.
Doesn't it aggregate under this inverse square law and become... Why is the mass of electrons and the mass of protons and neutrons and neutrinos or whatever, why is it those masses are kind of fixed?
Well, who says so, right? Again, so fixed by what standard? They could have variabilities that could go into hundreds of thousands of quanta, perhaps, and we'd never be able to detect those kinds of differences. So yeah, from our long view, they have a standard size, but it's really not a standard. And I think we can understand that. That most of the stars in the sky, oh, it all looks the same to me, right? Galaxies look the same as stars, and all that kind of stuff. So, I mean, it's kind of silly, I think, for you to argue that they know that electrons are exactly 100, let's say 1 million quanta, and they never are 1,000,001 quanta, and they're never 99,999 quanta. Bullshit.
In what they call the rest mass sense. But the biggest thing on the physics of late is his objection about gravitational lensing, right? There's an image Pyro shows.
Well, it's shining a light. This is not very useful, but I'll draw the image. So here we go. There's a galaxy. Here's the lensing. Okay, it's not even a complete circle. It has a little hard spot here, a little hard spot maybe over here, a little bit of hard here. Okay, and it's argued that this stuff here is really behind this thing, way behind it, and we can't see it, and it's being you know, through this. Here's the galaxy. Here's the galaxy we're looking at. Here we're looking at it. And so the idea is let's just make these things a little bit bigger so we can have some hope of doing this. But the idea is the galaxy back here, the light is hitting the lens and being bent to our observation. So that's the argument. Alright, my argument is Einstein clearly stated in his theory that the lensing would happen here in the strongest gravity. That photons are moving at such a high velocity that you would need intensely strong gravity to diffract them at all. And so if you were to see lensing, it would have to be very close to a gravitational maxima. It wouldn't be in the de minimis out here, which is at least 2 diameters of the galaxy out, which means that the gravity has been cut in like an eighth. Or more. It's like a 25th maybe, yeah. So there's 1/25th of the gravity here, here. And so there can't really be any hope of bending light way out there. And again, I'm arguing that lensing is a fraud anyway, that it's really particulates that bend light, and there's going to be particulates around any galactic any universal object that is spewing energy.
Whereby the lights, the gravitational lensing is shown as a ring of around the central galaxy, and he says this area way out here is an area of low gravitation by the inverse square law. And he makes a great trick about this. There's hardly any gravity over there. Surely it's close to the surface of the element, blah, 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 blah.
Well, I mean, to blah, 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 there's the fact, like I said, again, Einstein said you would never see, it'd be very rare to see lensing in space, because it's going to be so close to these objects he understood as stars and suns, that there would be no way for you to block out the light of the sun that you were looking at from a distant sun. The margin of error would be so slight between how much of the sun you blocked out and how you would end up blocking out the gravitational lens. The lens would be so tiny, such a little shred of a lens. And so that's Einstein's argument. I'm just pointing out how this new lensing they're saying, this gravitational lensing they have found, I'm saying quite explicitly and directly, Einstein would not say that's what I was talking about. Einstein was not talking about this at all. If he thought that could happen, he would have suggested, you know, going in lots of places, right, around our own sun. He would just say, look, just block out the sun. You don't need to be right next to the sun to see the lensing. Go 500 miles from the sun. Go 1,000. Go 1,000,000 miles from the sun, and you'll get plenty of lensing. You don't need to look right at the edge. Right? Right. And again, if lensing, look, you know, what is it, just a coincidence that our sun happens to lens a galaxy behind it, you know, that just happened to prove Einstein's theory, but all the rest of these objects in the sky somehow aren't doing all this lensing? How come every single one doesn't create a huge number of lensed objects that we can just show you a picture of, there's the lens, there's the lens, there's the lens, there's the lens? If it was that easy.
But the inverse square law says that the gravity never runs out, right?
Well, again, it does run out over space. So it does. That's the whole point. It spreads out and dilutes. The gravity, just 2 solar diameters from the sun, okay, is diluted by 1/20. It's now 1/25th the gravity. It's the same gravity as Earth, that far away from the sun. All you need to go is 2 diameters away from the sun, and the gravity is the same as the gravity on Earth. It goes from 612 miles a second acceleration to 22 miles a second acceleration.
He professes his theory holds to the inverse square law. So no matter how far you go out, it has an effect.
Well, again, if you want to say that you can create a lens no matter how far you go out, then why aren't there lenses everywhere? If I can go 1,000,000 miles from the sun and gravity is never interfered with in any way, and because the light has to go through a big round circle, it has plenty of time to get diffracted. Why isn't there a big giant lens around every fucking galaxy in the goddamn in the goddamn universe? This is such a crock of shit. I mean, this is not complicated. I mean, we know that this lensing thing isn't happening everywhere, and the point is where it does happen, we have a couple of phenomenons that just seem like they're overtly screaming for a better explanation. Again, the brightest galaxy ever found just happens to be a lensed galaxy. Now, doesn't that sound a little too coincidental that a galaxy 3 times brighter than any galaxy ever seen in the universe just happens to be invisible behind another galaxy, and we have to see it through lensing?
And the killer point here is that images, and he wonders why you don't see gravitational lensing around Pluto or this, that, and the other. Is that
yeah? Well, if you need just Earth's gravity, if Earth's gravity is enough gravity to create lensing, I mean, again, how many galactic diameters? Again, I understand a galaxy isn't solid matter. It's not like a sun. So you know the event horizon of a galaxy is probably relatively, you know, you have to do a lot of addition to figure out where the most gravity is because of the lack of density. It's not a solid object. It doesn't have a solid mass. So its gravity is variable in the field of the galaxy. So, I mean, a galactic diameter doesn't even equal a solar diameter in the sense that the density isn't consistent. And besides the fact that it's flat, it's not even a sphere. I mean, fuck.
Image that falls on the eye, the image that falls on the telescope is constrained by its position, by the focal point. Yeah.
Well, look, the argument with lensing is that you don't have to have a focal point. I mean, the focus isn't important. That's why Einstein was predicting you could do it with the sun and find just any old star back there, and the star is going to be changed in its position. So all the stars behind the lens essentially would be affected by the lens. There's no escaping lensing in a sense. So every bright object inside the lens would be lensed, and their position would be changed. So it's like if I lens a fish tank, all the fish are lensed into a different position. None of the fish look like they are where they are because all of the fish get lensed. No matter whether it's a fish in the background or a fish in the foreground, they all get moved to some extent. Moved in terms of our perception.
When you're out of focal point, you know, all we...
Again, they're photons, so there doesn't need to be a focal point because it's the amount of light that's being bent. So it's the bending that's going to automatically create some sort of... Well, I don't want to argue about lenses that have an infinite focal point, you know, where things are in focus to affinity. But that is a real concept, right?
You know, focal point. The information is just a mess.
Right, and this lensing image is pretty much a mess. All the pictures they show you of gravitational lensing look pretty messy to me.
You have to be within certain regions to actually get the image. You know?
Yeah, well, the argument would be is that all you have to be is in the lens. So again, the argument is that yes, if light's going outside the lens, it's not going to be lensed. But if it goes inside the lens, it will be diffracted at a certain point and it will have a focus, so to speak. But again, if you're off focus, you're still going to get some of that light depending on the distances. But again, it just doesn't matter because we already know that when they did this to confirm Einstein's theory of relativity, okay, they knew exactly what star they were looking for, they knew exactly what was going, and they knew they could lens it. Now, how did they know all of that?
You focus the point. You know, when you burn a hole in a piece of paper, you have to get it on the focal point. And so it is that we don't see gravitational lensing behind or at every galaxy.
But again, there's going to be points on the lens that will keep changing the focal point. So again, let's understand that the light coming from the object. So the object is shining beam rays of light, little straight lines of light. And here's the lens. So at each point in this lens, it gets bent a different amount. So it can end up at a different focal point. So that would be the argument, is that this distance can change because it can hit a different portion of the lens and be diffracted at the point where we'll see it. So yeah, we won't see some vectors and we'll see other vectors depending on where in the lens we see it. But again, I would argue the lens can't be nearly as wide as they're making the lens. It can't be this big a lens. It has to be somewhere in this region. So there isn't that big a margin for error for true lensing. Again, why did they bother? There's no, you know, I'm just saying if the sun could lens on something other than its surface, why did they look on its surface? Why didn't they just look further away?
Even though there will be stuff behind it, what you call the apparent image is related to, and how you see it is related to where you are in.
Yeah, well, even if, like I said, I'm accepting some necessity to be somewhere in some range of focus. Like I said, it can be out of focus to some extent, but it can't be preposterously, you know, there has to be some potential to bend the light into a place where you're going to be able to receive it. But again, we're talking about a universe that's got as many suns in it as there are grains of sand on Earth. I'm just saying that if with that many lenses, you should be popping lots of stuff. You should be seeing lots of shit. Lensed.
Context to the lens at play and the image, the object image, and the apparent image, right? This is child's play.
Right. Okay. This is child's play. So again, I'm just going to make this argument one more point. Just again, you tell me where. Show me in where Einstein said you could have lensing 4 or 2 or 3 diameters away from the gravitational object. Show me. Explain to me how the gravity this far away from a galaxy that's not a solid sphere, that this gravity would be sufficient to bend light. Show me the math that makes that gravity 1/25th the surface gravity, and who knows what the strongest gravity has to be, probably somewhere near the core of the galaxy, just because of the structure of galaxies not being solid. You know, the strongest gravity is somewhere beyond the event horizon, so to speak.
Inmendham is unbeknowing of. He has no theory of atomic structure. He has no accounting of.
I mean, what's the point of saying it? What's the point of saying it? I mean, I only detail it. I point out how every movement of it. I explain inertia, velocity, time dilation, you know, gravity, magnetism, attraction, repulsion. I explain all of this stuff and you say I've done nothing. I mean, it's just so rude. You don't agree with it, fine. You can't articulate me exactly why. No, it can't be particles. All right, you haven't explained why it can't be. You just say, no, I don't believe so. Okay, fine. You don't get it. Okay, but don't argue that I haven't explained it.
The periodic table, yeah, the valences of electrons, the electron configuration as described by quantum mechanics.
Well, again, what's described by traditional notions of wave theory, okay, really has nothing to do with anything I want to talk about, okay? You want to tell me the Standard Model is real, it's the real deal, it's what things are made of, and that's the way things are. Go ahead, fine. I've explained that this atom thing really isn't what they're talking about. It's a huge collection of a zillion little bits. And the probabilistic, it's all really just going to end up being about some sort of probability equation about stuff going in, stuff going out. Because the movements aren't really circles, there are all kinds of jagged lines in them and all that kind of stuff. It's like the orbit of the Earth around the Sun. We can argue that, oh, it's an ellipse and it's this. No, it's really a jaggedy, weird thing that each bit of quanta is actually traveling a very rickety road. And so in reality it's not what you think it is. So the fact that they have created a crayon drawing of the atom and put their little quark in and they're this and they're that, it's not really what it's doing. But what I'm arguing about, its force dynamics, I'm at least explaining where the force comes from. They're not. They're saying we bend time and space and that creates energy. And I'm saying that's a canard, that's bullshit. There's no excuse. There's nothing about time or space that creates energy. I'm explaining where the energy comes